you're always creating isosceles triangles. And so you have to know all of the postulates and theorems that go along with isosceles triangles. So go back to that section and review them. Also, a lot of times, this will work out, well, not a lot of times, but if it's a hexagon, this will work out to be an equilateral triangle. So then any postulates and theorems that go along with equilateral triangles will also be in effect there. So then the last thing, actually, I think the rest of chapter 11, circles, we did that in the last section. You'll still have to know how to find like perimeter or not perimeter, circumference or area of a circle. That might come up. But the rest of this unit, like sectors, we did that in the last one, in the last chapter. And ratios of areas is not going to be on this quiz, but it will probably be on the test. So the basic vocabulary, you have to know what a center is. A center represents the center of the circumscribed circle. So if we had a circle on the outside of this that was touching every vertex, then this point would be the center of that circle. So that's what we're talking about. The radius is a radius of the circle. So from the center to a point that touches the circle. But since every vertice touches the circle, the radius is from the center to any vertice. That's going to be called a radius. The central angle. The central angle is if you draw two radii in, this is your central angle. So actually, if we have a six-sided figure, how many triangles can we create? 6. We can create 6. This is 360 degrees. It's a circle. So to find the central angle, you're always going to do 360 divided by the number of sides, because the number of sides is equal to the number of triangles that you can create. So this one would have 60 degrees as its central angle. Okay, so far so good? Mm-hmm. Okay, so here's where they start to get a little different. First of all, recognize we have 3 ways to find the area of triangles. Basic premise is if I want to find the area of this regular hexagon, I'm going to find the area of this triangle and multiply it by 6. That's the basic premise. But then what happens is, in order to find the area of this triangle, I usually need to drop an altitude. Remember that an altitude will divide this base into 2 congruent pieces. It will divide this angle into 2 congruent pieces. So you actually have 2 congruent triangles here. So if you find, let's say, this triangle, instead of, you could double it and then multiply by 6, or you could just take the area of that triangle and multiply by 12, because each of these could be divided into 2 of those. Does that make sense? Okay. What formulas are we talking about when we talk about finding area of a triangle?
1/2 base times base.
Area equals 1/2 base times height. That's the old standard. That's the one you've known since probably like 5th grade. We know from trig 1/2 AB sine C, or 1/2 AC sine B, or 1/2 BC sine A. Those are all the same. And what's the last one?
More, but A equals RS. Or K.
RS,
The in radius on the semi-perimeter.
which is the same as 1/2 the apothem times the perimeter. Is this a math counts thing?
Not really. There was a Heron. We're doing this.
It was what?
Heron's formula.
Oh, Heron's formula.
It's
We're-
in
it's
it.
in- it's in
Yes.
It's in here.
Yeah.
Oh, okay. I was going to say, wait, don't we do that? Yeah. So are we okay with these? So when you're trying to find the area of the whole polygon, it starts with finding the area of the triangle. Any of these can be used to find the area of the triangle. Of course, we're going to try to use the easiest one possible. So trig is probably going to be our last choice. Not that trig is hard, but we also know we come up with approximations every time we have to use trig. So we're talking about probably trying to use those. So when you get, let's start with something simple and then I'll go to something more complex. So suppose you're looking at a hexagon. Hexagons are one of the easiest ones to work with because the triangle that's going to be created is actually going to be 60, 60, 60, which makes it equilateral. So if they give you a radius here, this is also the radius. So when we drop an altitude here, it's going to make this one 30. It's going to make 30, 60, 90. And we know that this is 1/2 of the radius and this is 1/2 of the radius because this entire thing was equal to the radius. Make sense? Okay. So then we're going to go to what we know about a 30, 60, 90. So we know that 30, 60, 90 is set up as x rad 3, and 2x. Those are the proportions of the sides. So if we know, let's say r is 6, then 6 is what part?
The 2x.
Okay, so that's the 2x, so we put a 6 here. So what's x?
3.
3, and then what's the middle side going to be? 3 rad 3. So now we can take that right triangle that we were looking at, and we know that this side is 6, we know that this side is 3, and we know that this side is 3 rad 3. So when you look back at this picture, we have a 3 rad 3 here. We have a 6 here, and we know half of r is 3, which makes sense, so this is 6. And then we can do base times height, so the height is 3 rad 3 times 1/2. And then that's the height, 1/2, and the base is r, which is 6. And then you just simplify that. So half of 6 is 3. 3 times 3 rad 3 is going to be 9 rad 3. We don't have to worry about plus or minus because we're not going to have any negative light. Questions? The harder ones that someone came up and was asking me about is there was a 12-sided figure.
That was good. Yep, that
And
was
then
good.
there was a circle that was circumscribed about that, and then all these little pieces here were shaded, and you were supposed to figure out the area of the shaded region. So we know that it's a 12-sided figure. And so some people came up and went, Ms. Romo, they didn't even show us the whole figure. How are we supposed to do this? Well, you don't need the whole figure. You just need the center. And you need to be able to draw a picture. So that's a radius. So in this particular one,
Page 450.
it's like 31 or something, right?
Yeah.
So in this particular one, they had this labeled as the radius, this labeled as the radius, and then they drew in this altitude right here, which was kind of interesting. So it says the diagram shows parts of a regular polygon with 12 sides inscribed in a circle with radius r. Find the area enclosed between the circle and the polygon in terms of r. So let's talk about general strategies. So we're going to find the area of the circle, and we're going to subtract from that the area of the regular polygon, right? That'll give you these little wedges. But to find the area of the 12-sided polygon, I need to find the area of this and multiply it by 12. So if I can find the area of this, I'll multiply it by 12. So how do I find the area of this? What would I do? Kevin?
I used 1/2 AB sine because you can drop the range, drop the altitude.
Yeah, I probably.
Okay, there's a way easier way. So what I would do first, central angle, right? I can find the central angle. I've got 360 degrees. I'm going to divide it by 12. What's each angle? 30. So I know that this angle is 30. So what do these two angles have to be?
60.
And actually that doesn't really even matter, because if I look at the right triangle that I have here, right, there's your 30. We know that's 90, so that's 60. We know that this side is R. So if we look at our ratio of x rad 3, and 2x, R is the 2x, right? It's the hypotenuse. So what is x?
1/2 R.
It's R over 2. So that means that this is R over 2. Well, R over 2 is the height of this triangle. So when we take R over 2, we can use area equals 1/2 base times height. So we know the base is R, right? That's this whole thing. Base and height are always the two that the perpendicular is drawn to. The base and the height will always be perpendicular. So if I'm looking at this triangle here, where this is the other side, and I'm looking at this full triangle, the base is R, so that's going to go here, and the height is R over 2, and it's multiplied by 1/2. So that's going to be 1/2 times, so it's going to be R squared over 4. So area equals R squared over 4 units squared. So when you're picking, when I first started doing this problem, I wanted to use this, 1/2 apothem times perimeter, because I was like, oh, I can find this, and then I can do the perimeter. And then I was actually working with Raymond, because I was like, Raymond, you're the geometry kid, right? And he's like, yeah. So we were looking at this problem, and he goes, stop. I was like, what? He goes, there's an easier way. You know the base, and you know the altitude. He's like, all you have to do is just apply it into the regular formula. So, but if I had gone through this process, would I have gotten the same answer? Absolutely. Would have gotten the exact same thing.
Two things. Why do you multiply by 4 squared?
Why did I multiply by what?
4 squared.
I think that's a U.
This is a U?
That's a U.
Oh.
Units? Units squared? I know you guys don't label in math counts, so that looks weird to you. Oh, God, yes. Thank you. That's only one triangle. So that's the area of one triangle, and then there's 12 triangles. So to finish the problem, I would have to take this and multiply it by 12. That would give me the area of the 12-sided plane figure. Then I would have to find the area of the circle using pi r squared, and then subtract the difference between the two. These questions are not short. It's not one little thing. It's a bunch of things. It's kind of like you're working your way through a detective story. You have to figure out this part, and then you have to figure out that part. So you want to have a game plan in mind. So I'm going to find the area of the circle. I will find the area of the 12-sided regular figure, and I will subtract it. But to find the area of the 12-sided regular figure, I need to find the area of this multiplied by 12. So in the book, they actually write it out like, so this one is like pi r squared, because they just gave you r, minus, so that's going to be the circle, and then they subtract 12 times the area of this. So I think they did something like 12 times 1/2 times r over 2. So this represents the polygon. This is one triangle. This is all 12 of them. Subtract it from that, and that's going to give you the answer to the problem. So that's actually the answer. These, you have to think through the whole problem. You can't just be like, oh, I found the area, I'm done, like I just did.
I still think 1/2 baby science.
Go back.